All right, let's hope for the best. Okay. So, remember that I told you that ER models are not necessarily relational. In fact, it's object-oriented, right? You have classes, subclasses. So ultimately, there's going to be multiple ways you can convert the same thing, but there are some rules. So we are going to basically follow the rules, and we are going to go through all the diagrams we did today and convert them to the relational data model. And, there are options, but, follow the main conventions, and it's fairly simple to do. So the first rule is that you are going to map entities to relations. That seems easy, right? I mean, that was kind of obvious. We said that your entities should be in Boyce code normal form. In fact, I'm going to take that entity, map it to a relation. Each entity goes to a different relation. And the key of the entity is mapped to the key of the relation. And key of the, and other attributes are mapped to attributes for a relation. That's pretty straightforward, except for weak entities. The weak entities we're going to do a little differently. So the weak entities I'm going to combine it with the relationship that they depend on, the so I'm going to take a weak entity plus the relationship that it depends on. Together, I'm going to map to a new entity. Okay? And I'm going to basically have the key of weak entity plus key of strong entities, possibly one or more, it depends on, is going to be a key of this relation. And then other attributes of weak entity will map to attributes of the relation. Okay, so let's do a few examples, and then we'll get back to the relationships. So far we are only talking about entities. So for all the entities here, I'm going to create a new relation. So I'm going to have one for book, which will have ISBN as a key. And then I'm going to have title, list price. Many more attributes may have been added while you are doing the quiz. Edition. So if this doesn't look exactly like what you have, it's possible I added stuff, year and URL. So I'm not closing this for a second. It'll become obvious in a minute. And then I had book copy, which had ID, condition, and price. I had author. It had URL, first name, last name, and bio. And publisher, name, address, URL. Right? So one of the things that you should kind of think about is when you're creating a model. So sometimes you will say, for example, suppose for the publisher, I can also store the number of books that they have published. Okay? So this is an example of an attribute that is legitimately a publisher attribute, right? But you can also derive that likely from just counting how many books that they have in the database, right? So if something can be derived from other information, I can choose not to include it for now, but later I may add it for performance reasons. So generally, what you want is to have only the information you need in the model and no more. So this is what I had. Let's look at what I would do for, and I'm going to come back to that when we do relationships. What we do for this one, okay? So this was the example of a weak entity. So for example, I'm going to have album has ID, date, and title. Whereas track depends on album through the relationship is in. So I'm going to take this and this together and map to a new relation called track, which is going to have album ID. So I'm going to inherit the strong relation that I depend on and my ID. And together they will be unique because we said that the key for the weak entity was not unique. And then we will have title and duration. Okay? So for the weak entity, the key itself is not unique, so inherits the strong entity as a key, and other attributes become attributes. So right now I have mapped this entity, and I have mapped this entity and this relationship together, right? Basically, I have taken care of because this relationship is telling me that I inherit the primary key from album. Okay, so we'll get back to these. Now let's do relationships. Relationships are going to be a little bit more tricky. If it is one-to-many, then I can map the one-to-many relationship as an attribute to the one side. So map this to as an attribute on the one side, pulling the primary key of the other entity. Okay. So let's try to see this with an example here. For example, here you have books are published by publishers, but for a book, how many publishers are there? There's one publisher, right? So since for a book there's one publisher, for a publisher there are many books. So the one side is the publisher, that a book has one publisher. Then that means for that book, I can store the publisher name as an attribute. So pull the primary key of this entity in here because of this one. So here, I'm going to have publisher name. Okay. So pull from the relation the primary key of the entity that you're deriving from. There's a book. For each book, there's a single publisher. Then store the publisher name. All other information about publisher is stored here. Because of normalization, this is what happens, right? You store things that belong here because name implies address and URL, but book has a publisher name and you can find this information here. Same thing is true for book copy. A book copy has only one book that it's a copy of, but a book may have multiple book copies. So I'm going to store, which one is the one side? Where will I store the information? In the book or in the book copy? So if I store in the book, I will store IDs of book copies, right? Which is not right because it's multiple. Whereas if I store in the book copy, I store the ID of the book. So I can just store book ISBN. Okay? You see that this is just that I am putting in that information as an attribute. It doesn't change the primary key. It is just an additional attribute that allows me to locate the information. Yes? In this case, this is a model as such. We will see the entity time to do the hobby. Okay? So, if it is many-to-many, then create a totally new relationship. Create a new relation with all keys of joining entities together is the key. Okay. Now this is true for many-to-many binary relations, right? So if this is many-to-many binary, basically the idea is that when you pull a relationship into a new relation, anything that is many should be part of the key. In the same way we were doing in normalization, right? So things that are many, they are not implied by something else, they have to be part of the key. So generally the idea is that many attributes should be part of the key. So in the one-to-many case, I pulled it to one relation. In the many-to-many case, I pulled it to a new relation. So wherever I pull the relationship to, so relationship attributes are mapped to attributes for where the relationship goes. Okay. So let's see an example of that. So I've already done published by. Published by is because of this. Copy of gets me that. But book has multiple authors, and an author can have multiple books. That cannot be represented by any of the other methods. I'm going to create a new relation. I'm going to call it book has author. Okay. You can change it later. You can just say, you can also sometimes call it book author. There is a very special name for these. They call them the join relations in like object relational models. So, which will have the book ISBN, the primary key of this one, primary key of that one, author URL. Since they are both many-to-many, the combination of the two is going to be my key. Now, the book had a listing order, right? So then, since I mapped this relationship to here, I'm going to make that an attribute here. Okay? And now I am done because I mapped everything else. So let's do, this one is done. Let's do this one. This is the one that was also exciting for us. Okay. So basically, since student is a strong entity, I'm going to have student ID, email, name, Okay. Then this is a weak entity, so I'm going to represent that as phone, which will have student ID, phone number, together are the key, and type. When I map this and this together, so I don't need to do anything about this. If I map this, it's exactly going to be this, right? Because for student, I have hobby name, and then hobby name and student ID together is the key. Now, if I were to map this one, hobby 2, right? That was the alternate model. So this was model 1. This model is a little different, which will tell me that I should actually store hobby 2 as an entity, like this. And then I have this multi-valued, many-to-many relationship that student has hobby and hobby has student. So student, hobby. So you have student ID and hobby name together. So this is model 2, all right? So if I represented it as a weak entity, I would get model 1. If I represented it as a strong entity, I would get model 2. Now you can say after I create it, I can get rid of that one. That's fine, right? That is your choice. But one thing that this model has that the other one doesn't have is you can see this as a way to control vocabulary. So suppose you don't want random and maybe ridiculous and made up hobbies that people are going to use to kind of make fun of the university. If you have an ability, please do that. So you're going to store all possible hobbies. And this way, you cannot store something here unless that it belongs to here, right? So this will allow you to do control vocabulary. So this is true for many systems of design. Sometimes you want to control the hobby, this gives you that. In the other one, you don't really have to have that. So they are both fine models. They have different applicability in different situations. Okay? So, but ultimately, if you had a weak entity, you would get 1. If you had a strong entity, you would get 2. As long as you understand the implication, I'm okay with that. Okay? One is not correct, the other one is not right. Like I said, data modeling is part science, part art, and part magic. You have to see what works for you, and, it is debatable which one is better, which one is worse. That's all I'm saying. Okay, so the last thing we have left is hierarchies. Hierarchies, you have many options, okay? And again, this will depend on whether your hierarchy is covering, it is disjoint. One may be better than the other one. So generally speaking, we have 3 options. One could be that you map everything in the hierarchy to a single relation. Then I can map each entity to a different relation. And then I can map each sub-entity. Then I can do kind of an in-between. Map parent entity to a relation. And then map sub-entities to a relation, but only for new attributes. Okay. Let me show you what I mean. So in model, let's start with model 2. Model 2 is the easiest. I'm going to have one entity called B. B has an ID and an A attribute. and it has a B attribute. And C has a ID, A attribute, and a C attribute. Okay? Do I need to create another relation for A? Only if there are A's that are not B's or C's, right? In that case, I also have to have an A that is an ID and A attribute, if not covering. Well, you can say that instead of storing all this additional information, I can store only what I need. I can create just A attribute, and for B, all I need is the ID and B attribute. And for C, all I need is the ID and C attribute. Okay? So the issue here in this case is that if I want information about B, I have to join A and B. If I want information about C, I have to join A and C. And if I want information about only A, I can do this. You can actually create this exact hierarchy in many databases. Okay? Or I can do the simpler thing. I can create a single relation. It has ID, A attribute, B attribute, and C attribute. Okay. Now in this case, you also have to say for each tuple that you store, if that tuple is an A, is a B, or is a C. If it can be only one of them, you can store a single attribute. If it can be any one of them, if they are not disjoint, then you have to have three attributes, right? You can have is A, is B, is C. Okay? So all of these models have trade-offs. This model is kind of complicated because if you have lots of special things for A's and special things for B's, that you will have lots of attributes that have no value. When you have an A, you will have empty values for B, and your program is going to be complicated because you have to make sure you're using this relation for many purposes. This one is a problem because you may need lots of joins because you spread information to multiple places. Okay? But if you don't really need this most of the time, this may be fine. And that one is okay, except you are now copying the same information. If somebody can be A and B at the same time, or B and C, then you are copying their information, which is something we wanted to avoid. So there are all valid solutions that is just fine. All right, so here's I have one last one. It's just a clean version of what I had before. So let's go through the exercise of this just very quickly. So it will depend on what this relation is on how you convert. So for example, if I create a relation for people and a relation for student and staff, right, then this relationship is going to basically map to separately. So let's say I create, all right, so actually, let's try to write it here for a change. Let's say I have people, RIN, name, address. I know that there are 200 people waiting outside, but I'm going to be fast. All right, I have student that has, in addition to RIN, has year and GPA. You have faculty that has RIN, title, and office. Okay. This is model 2. And now, for example, this is a useless relationship. I just put it there so we can see that people can be related to other people. So this is a many-to-many relationship that's going to create a new relation. So I'm going to say related to. So this is now a recursive relationship. So it relates one person to another. So I'm going to get primary keys from the same. Yes?
So, can you go back to the piece of paper that details the 3 different ways to go about hierarchy?
I'm going to scan that. Let me just do this quickly because we have like 2 minutes. Okay, I will get back to that. Rin 1, Rin 2, right? And then type. All right? And then, for example, you have department has name, phone, and office. You have major that has a name. Okay. Then we have multiple relationships. One is that majors are for a specific department. So this is a 1. So I can put for major the department name. Faculty is chair of department. This is a one-to-one relationship. So you can actually represent it here or here. It can go either way, right? Faculty is chair of department, so you can store the department ID, or department has a chair. But not every faculty is chair, whereas every department has a faculty that is the chair, right? So because of that, I am going to move it to the department that it has a chair in. One-to-one, you can take it either way, but this happens to be better. Okay. Faculty works in departments, so for faculty, you have the department name. And I'm going to scan these and put online so you can see that. Okay. So the last thing that I have is I have this, which will be minor in, student RIN, and major name. And then let's do this one. So student has major and advisor. This is the ternary relationship we had. So this is many to many, 1. So it's at least too many. So I'm going to create a new relation. So advisors, which will have student RIN, major name, and faculty RIN. Okay. And I also have order. Now remember that student and major implies faculty, so my primary key is going to be only these 2. Given a student and a major, there's a single faculty. So the rule is that when you have many to many, you don't really need to have every single entity in here, only have to have the entities that are in the many side that is part of the key. Okay, so with that, I'm going to stop here, but here you go.